Hello everyone. Today we are solving this question from Leetcode, smallest unique subarray, which appeared in today's weekly contest 502. So here is the problem statement. You are given an integer array nums. Find the minimum length of a subarray that is not identical to any other subarray in nums. Return an integer denoting the minimum possible length of such a subarray. Then the subarray definition is here. Alright. So let's say you have an array and we have to find the minimum length of a subarray which is unique in the array, which is not repeating anywhere else. So the first thing we can notice here is, let's say we have some subarrays 1, 2, 3. So we can see here that its length is 3. Now this function is monotonic, as if our answer is 3, that means 1 to 3 is not anywhere else. Then anything greater than this, after extending this, will not, let's say here x. Here comes x. So 1 to 3 x, where x can be anything, will not be in the subarray. Because if 1 to 3 x in the subarray, then 1 to 3 will be matching. And we already know that 1 to 3 is not present in the subarray, in the array. So that means our function is monotonic. So we can apply binary search on length. So what we'll do is we'll take lengths, minimum lengths. The low and high for the binary search are 1 and n, and we will binary search on that length. We will see if that length subarray has any unique distinct subarray which is not repeating or not. Now how we can do that? So firstly we can look for that. Let's say if we have length is equal to 5, then we will generate all 5 length subarrays and we will store them in some data structure, and we will see if there is any unique subarray between those all subarrays that you have generated for that length. Now this will be very time costly. Its time complexity will be high square. So we need to do some algorithm to figure out how to do this part. This one length subarray faster than n. These all are O of n, and there are n of n subarrays. So that's why n into n becomes n squared. So we need to figure out any way such that this of n becomes of 1. And there are n total number of subarrays for a particular length. So in total our time complexity will be log n for the binary search multiplied by of 1 multiplied by of n. Overall we can solve this problem in n log n if we can figure out any way in which particular we can find out any particular thing for a subarray in of 1, and that will be our hash. We will be solving this with the problem with the concept of rolling hash. In this, what we do is for a particular substring or subarray, let's say 4, 5, 4, 7, 3, we will generate a unique number for this by passing through a function which we call hasher, and we get a unique mapping for this to a particular number. Now, this is not a one-to-one mapping. What I mean is, we will not have a very indifferent relation between this and this. Our function will be in such a way that we can relate two subarrays like 5, 4, 7, 3. So this part, let's say this is k, and this part, let's say this is t. So there will be some relation between k and t. It is not like they are both completely different. So to summarize, Firstly, we will by a search of the length from 1 to n. This will take log n steps. Then we will generate all subarray hashes for that length. Let's say we have length, then generate all hashes of n. Then using hash, then we will just check there is if there is hash that is not repeating. Find if not repeating. So now let's start a query. So firstly, I will take the size of the hash int n is equal to nums dot size, and for by search my int low will be 1 and int high will be n, and my answer will always be n. And if I can find out less than that, it will be better. While those is less than or equal high, it made equal low plus high than 2, which is check estimate nice. Then I can find better length, so answer will be mid, and I is nil, else though will be mid plus. This is the standard by search, not just works, and it must have the time. So now I have to write two functions. First is the check function. We check where I will have int length and vector independent range. Let me quickly write the hasher. Uh, hasher. This will have a constructor which will take our array. Hasher has many two vectors. Vector inquiry which will store the prefix hashes. And one another vector. Uh, in hasher function, we also have two integers which are base and not. So since our constraint says that the nums of I can be up to 25 10 to the power 5. So our base can be any number, any prime number which is greater than 10 raised to power 5, and which is a prime number. So I can say 1311313. Okay. And our mode will be y9 plus 7. Now I will leave over the array to populate the p and powers to store powers to store uh, the powers of bases, base to the power 1, 2, 3, and 7. P of I plus 1 will be base times t of I plus nums of I. This is simple modular arithmetics and powers of I plus 1 will be powers of 0 and 1. Anything just for 0 is 1. And powers of I plus 1 will be base times powers I. So this will create our hash array. Now we create a function get hasher from the range L to R. The length will be r minus p plus 1 and the answer will be p of L. Now this is 0 based and RB is 1 based. So R plus 1 minus p of L times power of N. This formula is a basic formula for rolling hash. We can search anywhere and we have to take note as well. And since there is a negative term, so first I will do plus mod, then W with mod. Plus lab, premium lab, return answer. Here I will just call this hasher function. Hasher one, and here I will pass my hashes. Now here for every length, we also need to pass the array. How do I pass this? Can I pass? Can I pass a struct to function? Let's see. It's this young vector of n hashes. This will contain, let's say I create a set or I create a map of 8, 8 and p, which is hashes 3 times c. Now for n print I hidden I is less than n minus 1 I plus plus. and h is equal to hash dot get hash from the range I to I plus n and square. If I took here 1 minus blank is which HP equals. Now if I find out any edge with sequence is equal to 1, then I'll return yes. So auto v p 0 second equal to 1 return loop. Otherwise it if I do not found any hash with a frequency 1, then I'll return false. Then return false. Okay, so everything looks fine. Let's see. Here is some syntax for compile every error. Reference my life will not judge how far it belongs. So what mistake I was making was I was not resizing this tree and parts. That's why we were getting out of bounds success. After that I ran the program. It ran for the example test cases. Now let's submit this. What accepted. Thanks for watching.